Right, welcome today. We've got just two questions today. One all the way, the first one, a GCSE question all the way from Devon for today. Should be reasonably straightforward, the starting one. And if you spot it, actually the second half is quite straightforward too. But if you don't spot it, it's not so straightforward. So hence why this student sent it in. You can see they're working. Let's see if you can work out if they got it right or wrong. So here's 2 minutes. Okay, so there you go, 2 minutes. So the function machine, we've got an input times by 3 plus 2 gives us the output. So let's just say our input is x. And we're going to times that by 3, then we're going to add 2, and then we get our output. So times x by 3, we get 3x, add 2, and this gives us our output. And then what's happened is the output is taken and put back in as the input. So we're going to take 3x plus 2. And then we're going to times by 3. So we get 3 times 3x plus 2. And then we're going to add 2. And that equals our new output, which is 26. So multiply out these brackets. Well, we can take the 2 off both sides and multiply. Well, no, I'm going to multiply out the brackets. Most students prefer to do that first. So 3 times 3 gives us 9x. 3 times 2 is another 6 plus 2 equals 26. Take 6 and 2 away from 26, we get 18. So we get 9x equals 18. So x equals 2. So our student was correct. Now, what he's done is gone backwards twice. So another way you could do is you could start with your output of 26, take off 2, gives you 24, divide by 3 to undo this, gives you 8. And then go round again. So we're starting at 8. We take off 2, we get 6. We divide by 3, that gives us 2. And that gives us our answer by going backwards through the machine twice. And when you go backwards, remember you've got to do the opposite, minus 2 and divide by 3. Now a new number is input into the machine and it gives an output which is double the input. Find the original input. So let's just have a look at this. So our output we now know is equal to 3x plus 2. And our input was equal to x. Now our output equals double our input. So 3x plus 2 must equal 2 times x. Equals 2x. And then we can see x plus 2 equals 0. So therefore x equals minus 2. And we can check this. So if we got minus 2, and we put it into our function machine, so you get minus 2 times 3 is minus 6, add 2 is minus 4, and that is actually double our original value. So we can see how that works. Right, next question. Okay, the GCSE students will probably switch off now because we got a nasty little A-level question. What I'm going to just do is just going to zoom in a little bit so you can see that more easily. Okay, I'll give you a good 3 minutes to think about this one because it's not straightforward. Right, let's look at this question now. Right, let's look at this question now. We're going to prove if x1, x2 and x3 are consecutive odd numbers, then the difference between their product and their sum is always a multiple of 6. So let's get 3 consecutive odd numbers. So we've got 2n plus 1, and we've got 2n plus 3, and we've got 2n plus 5. I'm just going to rub out that because actually what I'm going to do is I'm going to start off multiplying them out straight away because I'm going to run out of space otherwise. Now we know these are odd numbers because 2n is even and add 1 makes it odd. So if we multiply those out, there's one way we can do it. We can do it like this. We can do 2n plus 1 times 2n plus 3. And what I'm going to do is I'm going to take off 3 of this because that will give me 2n plus 2. And therefore, obviously, I've got to add on the 3 here times by all of that. So 3 times 2n plus 1 times 2n plus, sorry, it's just squeezing it in on the edge of the screen, 2n plus 3 there. And what I'm just going to reorder these a little bit so as to make it easy to see. So you've got 2n plus 1, 2n plus 2, and we've got 2n plus, sorry about that, 2, turned it into rubber, 2n plus 3. And what we have is we have 3 consecutive numbers. This is 1 more than 2n, this is 2 more than 2n, this is 3 more than 2n, so they must be a multiple of 3. And then these numbers here must be a multiple of 3. Okay, so they're a multiple of 3 and they are a multiple of 3. So basically we have the sum of 2 multiples of 3. Okay, so we know that they must be a multiple of 3. Now we also know that the 3 numbers originally, okay, are 3 odd numbers times together, so they must be an odd multiple of 3. This also is an odd multiple of 3. Now if we look at the sum of these numbers, so we get 2n plus 1 plus 2n plus 3 plus 2n plus 5, we get 6n plus 9. Okay, and this is also an odd multiple of 3. Now we know it's an odd multiple of 3 because 6 times n is even, because that's a factor of 2 there. And we know this is a multiple of 3, and we know this is a multiple of 3. Because this is even and we're adding on an odd, we get an odd number. And because 3 is a factor of it, we know it's an odd multiple of 3. Now the difference between 2 odd multiples of 3 is an even multiple of 3. Okay, so the difference between 2 odd multiples of 3 is an even multiple of 3. Okay, and an even multiple of 3 must be a multiple of 6. Okay, so the answer must be a multiple of 6. Just think about that. 2 odd multiples of 3. So let's take 2 odd multiples of 3. Let's look at 9 and 15. And you can see the gap between these is 6. Yeah, because in between them is an even multiple of 3. And basically in between every odd multiple of 3, there's an even multiple of 3. And the gap is always 6. So therefore, if we go, say we're doing between 9 and the next one's 21, then the gap will be 12. You're always going to get an even multiple of 3, and an even multiple of 3 is always a multiple of 6. So hence we have proved that the difference between their product and their sum is always a multiple of 6. So those are our 2 questions for today. This question, I would suggest you have another look at this video again, because I'm sure many of you struggled with it, and pause it and try and see if you can remember how to do it. Thank you.